So the last thing we talked about was the dot plot. You could see the distribution, right, how the data varied or how it was clustered using the dot plot. We have something else called a stem and leaf display or a stem and leaf plot. It displays the data of each sample using the actual digits that make up the data values. Each numerical value is divided into two parts. The leading digit or digits becomes the stem, and the trailing digit or digits become the leaf. So what do stem and leaf displays tell us? A stem and leaf display gives a visual display that shows all the data or truncated data in order from smallest to largest. It helps us spot extreme data values or clusters of data values, and it displays the shape of the data distribution. You know, is it clustered in the center and then more sparse at the extremes, like lower and higher values? Or is it gathered on one end or the other? So we have the daily high temperatures in Fahrenheit are given for September 1st through October 5th. We're going to use the temperatures to create a stem and leaf display, also known as a stem plot. Sometimes I'll say that. I'll say make a stem plot, and then the next time I'll say make a stem and leaf display. They're interchangeable, okay? So we have these data values. How are we going to split this so that you have the stem and the leaf? What's the stem part going to be, you think? Yeah, nice. So he just said it. What do we need? What's the smallest? We have 8 would be the stem, he said, or 7. Here we have 8, 8, 7, 7, 8, 7, 8, 8, 7, 6. So we need a 6 and 5, yes. So on the bottom of yours, I gave you these values. Because I can't draw a straight line, I was trying to be your friend and give you this, right? All right, so we definitely need a 5, and we have to go all the way up to 8. Give yourself some space, so 5, 6, 7, 8. Okay, and then this is supposed to be from smallest to largest, and let me say this. Even if your lowest value was a 5 and then you didn't have any numbers till the 80-somethings, you still have to put the 6 and the 7. You just leave those blank, those rows blank. But you can't skip numbers over here. Once you start, you have to keep going all the way up consecutively. Okay? All right, the next thing I would suggest doing is organizing this somehow. You know what I'm saying? So that you can get your numbers in order. So, like, I'm going to put my 80 right here and cross it out, then my 77 right here, then my 81 right here, and 85, 73. You see what I'm doing? I'm trying to organize my data so that then I can put it in the stem and leaf easier. 73, 80, 72, 83, 81. So I should have 10 values so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Then 75, 78, 80, 71, 73, 78, 75, 63, 63, 70, 77, 82, 81. I'm going to move these two down so I have some room. Excuse me, 76, 77, 76, 74, 66, 66, 62, 71, 68, 66, and 71. And if you want to, you can write the 58 down there, but I mean, it's literally the only one. All right, so how many data values should I have? 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7. 5 times 7? 35. I always double check because it's very simple to leave one of these out, you know what I mean? So it's easy to make mistakes. So I always just double check myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So now that they're organized, it's kind of easier for me to put them in the stem and leaf. So I have the 58, so I'm going to put an 8 right here. You don't skip and go out here where you think an 8 would be. You don't do that. Then I look, and I do have to organize the 60s. So I have, what's my smallest? 62. And then I'm going to leave a little space. Do not put a comma, just leave a little space. Then I have 63, 63, right? I might have left too much space, actually. I'm going to put them a little closer. 63, 63. So 62, I got that one. 63, 63. So then I need 3 6s and an 8, right? All right. So I got all those. Now I need to do the 70s. The smallest is 70 itself, right? And then how many ones do I have? 1, 2, 3. So I have 70. Notice I'm lining these up. 1, 2, 3. You have to line them up kind of like in columns. You can't squish these together because you're like, oh, I'm going to have way more 7s. And so you squish them together because that will skew the data. You know, it makes it look different. Okay, so you have to leave the same amount of space in between. So then we have 172, and then 1, 2, 3, wrong way. So 172, and then 3 73s, right? Are you checking yours? Make sure I'm right. 172 and 3 73s. Okay. And then 74. I had there's 174. And then 1, 2, 2 75s. So 174, 2 75s. I'm probably going to run out of room, but you all have way more room to write probably on your paper. You know what I mean? You're not using a smartboard. So 75. Two 76s, y'all agree? And then 1, 2, 3 77s. I would just keep going and put my 77s. I don't have room, but y'all should. 3 77s. And then 2 78s, right? All right, so you see how to organize it. Go ahead and do the 80 row. Yes, thanks for asking. 381s, right? 1, 2, 3, then 1, 2, 3, then 82, 83, 85. 82, 83, 85. All right, so Daily high temperature stem plot, that's not how you would name this. So we would name this just daily high temperatures. And then I actually, in parentheses, would probably put Fahrenheit. You know what I mean? Like put F or Fahrenheit. Somebody might not know what that F means, so I'll put. Did I spell that right? Fahrenheit. That's a weird word. HEIT. There we go. So, this is given in Fahrenheit. People know that now. You also have to include a legend. So just pick one of these numbers. I like the 70. So I'm going to do 70 line 2 equals 72 degrees Fahrenheit. You must include this. It's a key, a legend. Because that could have been the 7 line 2. That could be 7.2, couldn't it? Or it could be 0.072, right? So you have to give that so people know. What does the stem plot suggest about the distribution of the temperatures?
To the 70s a lot.
Yeah? Y'all? Nobody else? It was in the 70s a lot. That's it? Really, y'all?
Rarely hit 58.
Trying to get how you said it. A lot. Trying to emphasize that.
It was like double and triple.
Right. So based on this, you would say the majority of the data, or the majority of the time, the temperatures were in the 70s or the 80s, right? Yeah. Rarely was it in the 50s. You know, based on that, you could try to make a guess of where they collected this data, right? Yeah. Because the majority of it's in the 70s and 80s as opposed to in the 50s and 60s. Definitely not Virginia. We have wonky weather. Okay, it's your turn. I did the first one with you. Okay. The ages for homes and years sold in Dutchess County, New York are given below. Use the ages to create a stem and leaf display. And yes, organizing it takes a little bit of time, but as you saw, I think it does help you, right? Let's go ahead and do that. All right, if you look at this, it looks like the least amount of years is 6, right? 6 years old, and the highest value is 144. So that means you should have started with 0, right? For 6 years. To put the 6 over here. How many of them were 6 years old? 3. And then once you start with 0, you have to do 1, 2, 3, 4, 5, 6, 7, all the way up to what?
14.
Yeah, you should have went all the way to 14 because that one house was 144 years.
Could you have done the thing where you like put the 2 lines in the graph?
And break it?
Yeah. Because there was no values after 7.
Right. I've never seen a stem and leaf with that in it. I've seen it on dot plots or bar graphs, but I've actually never seen it with a stem and leaf. So I don't know that it's not allowed. You know what I mean? I don't know. I'll have to Google that. He asked if you could put the break, after 7. All right. I think it really emphasizes that that one house is super old compared to all the rest. When you see that all of these values down here don't have anything. All right, you should have put a title up here, right? Ages for homes. And then in years in parentheses maybe. And then you should have also made a key. So the 1-4 with the line 4 is equal to 144 years. And then did you count, make sure you got all your values? Compare your stem and leaf with the person beside you right now, because I'm not going to put all those numbers up there. Make sure you agree. I see you're counting. Thank you. Make sure they're all there. So do we use commas in a stem and leaf? No. If you Googled it, you would see some online have commas. You don't trust everything you see online. Yeah. We don't put commas. We don't worry about the grammar part of this right now. Okay? All right, are you good? Any questions? No? All right. Everybody agreed with the other persons? Great. When you have overlapping distributions, look, I included this instead of making, instead of us doing another example. Just look, though. So we have a random sample of 50 college students that were selected. Their weights were obtained from their medical records, and then the resulting data are listed in Table 2.3, which is below. So notice that the weights range from 98 to 215 pounds. So if you group the weights on stems of 10, then the leaves have to be arranged in order. But if you look, you have male versus female, right? And you have 50. It's just telling you they gave them the number 50, to keep up with. And then whether or not they were male or female, and then how much they weighed. So that's a lot of data. If you look, if you group it like this, it just puts the weights all together. So you can't really see. You have a mound right here, right? And you have another mound right here. But you can't say the majority of the data falls in this range or this range or this range. You see what I'm saying? But if you separate it and you put the female and the male, when you see 0, 9 like this, that's still the stem. It's not the leaf just because it's on the right. So this is overlapping distribution, and you put a back-to-back stem and leaf. You can see the numbers that are clustered up here were the female's weights, and the numbers that are clustered down here were the male weights. So you can do a back-to-back stem and leaf by separating it. If you had had an outlier, if you had a female weight up here or a male weight down here, you would still put those values on the correct side. Okay, it just works out that it shows you the majority of the females weighed between 110 pounds to 118 pounds, right? They're right here. Whereas the majority of the men weigh, this one's kind of harder to see. You see what I'm looking at? It's kind of like this. So they're kind of more right in here. In the 160 range. Yeah. So a back-to-back stem and leaf is sometimes helpful. Split your values. Maybe on this house one, we could have split the values, right? But how would you split it? Brick homes, you would have to have more information. You can't just say, well, I'm going to put from the single digits to 4, and then, you have to have some kind of identifier. All right. And then I put stars and, really try to make this important. For any graph, you must provide a title, you must label the axes, and you must identify the units of measure. So that's why we were putting in years or temperature in Fahrenheit, okay? As Edward Tufte suggests in his book, The Visual Display of Quantitative Information, don't let artwork or skewed perspective cloud the clarity of the information displayed. So when you do projects for me, I will say, personalize the graphical display, make it your own, make it visually appealing. However, don't distract from the information. Okay? So let's look at some bad graphs. I already went over the squiggle, changing the scale, right? Or breaking it. You don't have to use the squiggle. You can also break it, remember? Bad graphs. Look at this first one. Do you agree with the court's decision to have the feeding tube removed? It's showing you the Democrats 62, Republicans 54, and Independents 54. The percent who agree.
So far apart, but 62% is not that much greater.
Why are they so far apart? 62 is not that much greater. But look, the increments are evenly spaced on the side, are they not?
Yeah, but it makes it look way extreme. 62 is not that much more than.
Why? What is making it look so extreme? What about it?
They're going up hard.
Ah, they started at 53. If you start at 0, like you're supposed to, it looks more realistic. It's more accurate. You always have to be careful when you're presented information to make sure they aren't purposely messing with your perception, right? So on the last one, do you know how many people would read that and would have no idea? Okay, thank you for your honesty. Would have no idea that they mess with it at all, right? So always look at the scale, always look at the starting value, and really scrutinize any graphical display you're ever given, all right? Because they know how to change it to get their idea across, their point across, okay? That is very common, very realistic. All right, look at this one. Annual incomes of groups with different education levels. If you look at this top one, it says advanced degree, they make $74,602. With a bachelor's degree, $51,206. High school diploma, $27,915. And no high school diploma, $18,734. Why do you think I have this as a bad graph?
It's hard to read the picture. The dollars weird.
Yeah, it's hard. The dollar is making it harder to read and interpret, isn't it? Yeah. And then if you had your bars and they're touching, where they're touching, squished together like that, that's also skewing your perception of it. With a bar graph, they're not supposed to be touching like that. There should be space in between. That's a histogram, yes. We talked about that a little bit the other day. All right, here's the same information, but portrayed differently. It's a better graph. It's still inaccurate, though. Why is this one a bad graph? It doesn't seem mathematical. No. Should you ever use a three-dimensional object to portray like a one-dimensional thing, or 2D, like make a bar? Yeah, it's making this look way bigger than this, right? Because you have 3 sides now that are that length, and then it's 3 times. It's so you never use a three-dimensional. Okay. Right. They're doing it based on volume. It skews your perception, okay? So always make graphs your own. That's a good thing. Make it your own. However, you have to be careful that you don't make it a bad graph, right? So your homework is worksheet 3. I'm getting ready to give you that, all right? And it's due next class.